Good morning, Year 12s. Right, so here comes our second lesson that we've done online together. I hope the first one went okay. I hope that the online learning was okay for you, because I know you're probably pretty well practiced at it now, so I hope it was okay. My goal today is I'm going to try to teach you two new topics, sketching quadratics as well as disguised quadratics, and I'm going to try to make the video a little bit shorter if it's possible, but I'm not all the way sure if I can pull that off, but I shall try. So good work on as well on submitting the homework on Show My Homework, as well as accessing the work on Show My Homework as well. So I'm happy with how this is going, and I look forward to actually seeing you in person next week. So that'll be good. Cool. Okay. Sketching quadratics, buddies. Basically, you guys know a great deal, I think, already about quadratics. So if you look at the mouse, quadratics are always shaped like this, like a kind of U shape. So they call that a parabola, actually, but it's either like in a U shape like that. If it's positive, like this one is, the x squared term is positive. See, it's not got a minus in front. That means it's going to be shaped like this. If there was a minus in front of the x squared term, it would be shaped down like that. So it'd be like kind of an N shape and not a U shape. So that's basically what that is. I know you're pretty familiar with that from GCSE, so let's rock on. We want to do sketches of these, which means we don't want to use tables of values. It doesn't have to be perfectly accurate or anything, but we do have a certain degree of accuracy that is required at A level. So let's have a little bit of a look. The things we need to find are the roots. Now, in case you don't quite remember what a root is the x-intercept, okay? It's where it crosses the x-axis. The y-intercept, which is nice and easy to find, also where it crosses the y-axis, and the minimum and the maximum point, which is the hardest thing to find. But, fortunately for us, we know a way. We know a complete way to do it. A completing the square way of doing it. So, yeah, cool. So to start with, guys, I'm going to start with the hardest thing first because, I don't know why, because I like to do the hardest thing first for some reason. Okay, so if you check it out, this guy here that we're looking at is positive x squared as its lead term, as its dominant term. That means it's going to be a U-shaped one, so it looks like like a U, which means it bottoms out, which means what we're going to be finding is a minimum. Now, in order to find that, my lovelies, what we're going to do is we're going to do some completing the square. Now, you know the way that I do it, which might not be quite the same way that you do it, but I like to do the thought bubble because it makes me get it right every single time. Now, the two things were, again, in case you couldn't remember, you have to half the second term, half the x term. So if you half minus 5, it's just going to be minus 5 over 2. Cool. No sense using decimals. It's easier without. Next up, square that bad boy, and if you square it, it's going to be positive, and it's going to be 25 over 4. So your very first step is going to be this. Y equals x squared minus 5x. Then you go plus 25 over 4 minus 25 over 4, and then your plus 4 follows. So just like what we did last week. Now, as if by magic, these first three terms, it didn't come in green. These first three terms are guaranteed to be a perfect square, which means they factorize to two brackets that are the same as each other. Now, you know, because you're boss at this, that it's just going to be this, x minus 5 over 2, all squared. You knew that again one more time because you just nicked this thing from the thought bubble and whacked it in there. So that's all there was to it. Now the other bit, the more complicated bit I would say, is just working out what this is. Now you can use a calculator, so don't worry too much about mental maths here. I don't think I have one to hand, so I'm going to have to actually work it out. So this is minus 25 over 4 plus 16 over 4 because that equals 4. So that's 9. Is it 9? Minus 9 over 4? I think it is. So minus 9 over 4 is what we're going to get here. Minus 9 over 4. But again, you can do that with a calculator. Cool. Guess what, guys? That's perfect completed square form. Now, here's how you find the minimum value from that. This is actually what completing the square is largely for. It's like one of the only uses of it now that, because I know that you guys already know the quadratic formula. Here's what you're going to do then, buddies. Check this out. The minimum value is going to just be found as follows. See the minus 5 over 2? Well, actually, let's do the whole equation. See this whole equation here? it's actually equal to the black one at the top there. So it's the same equation, even though it's written in blue, even though it's a complete the square format. It's the same algebra, so it's the same numbers, it's the same equation. Now, when it's in completed square forms, I can ask myself the question, what number can I put in for x to make the whole answer the absolute smallest? Well, you might be thinking, well, couldn't you put in a big negative number? Like if you put in negative a million or whatever, that would mean that almost this minus 5 over 2 would be useless. That wouldn't even count if you had like negative a million in there. Well, if you did negative a million and you squared it, it would actually become a great enormous positive number. So negatives don't really work. If you put positives in here, positive a million, and squared it, it would become a great big positive number again. So positive numbers don't work either. The smallest number I can actually get is the number which makes this whole bracket equal to 0. Because whenever you square something, it goes positive. So the smallest number that you can get to come out is 0. The number that does that, what would be the number that does that, that makes x minus 5 over 2 be 0? Well, if you said 5 over 2, you're absolutely right. Because if you popped 5 over 2 into here, it'd become 5 over 2 take 5 over 2, which is nothing. And then you go nothing squared, which is still nothing. And then minus 9 over 4, which would be minus 9 over 4. So our total answer here is that. That's the minimum value that you can possibly get. So that's like the main thing already done and dusted. Oops, it didn't come in blue. This is the main thing done, already done and dusted, the hardest thing. The minimum value you can read from completed the square form. All you have to know in order to read it from completed square form is the number that makes the bracket 0 and this number here on the edge, which is chilling out, is chilling out just because when you put 5 over 2 in, it kills it all off. So there you go, the minimum value, we've got 1 point. Okay, that was the hardest thing. Let's go easier now. Y-intercept is dead easy. Now, the y-intercept, guys, if you just remember, we're going to be doing a sketch here. So it's going to be like on graph paper like this. If you think, where the y-intercept is, well, it's anywhere on this line, right? So what's equal to what on this line? Well, if you said on the y-intercept line, it's actually just the y-axis. And if the y-axis is defined for where x equals 0, cool? Because x is 1, 2, 3, 4, 5 here, it's negative 1, 2, 3, 4, 5 here. So on the axis itself, it's 0, so it's x equals 0. Well, this should be so easy for us now. All we have to do is pop x equals 0 into the equation. I'd suggest the top one, the black one, because it's the easiest. So let's pop into it. So it'll be y equals 0 squared minus 5 times 0 plus 4, which means y is just equal to 4, right? Because the 0 ones just disappear. So bish bash bosh, you've got your y-intercept. Cool beans. Only one thing left for us to find. And the final thing that we need to find is called the roots. Now, in case you don't remember what roots are, roots, again, are where a function, say the function looked like that, like I'm doing with my mouse, that would be where it crosses the x-axis. So same deal with this. It's going to be where y equals 0, that means. So here we go, where y equals 0. Now, the reason why, one more time, is if you think about it, along here, this is going to be where y equals 0. Yeah, so we're on the x-axis. So this would be like where y equals 1, 2, 3, 4, 5, 6. This would be where y is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So right here in the middle, y is 0. Which means we're just going to be solving this equation here. We're going to be solving the equation 0, because I'm just popping 0 in for y, equals x squared minus 5x plus 4. Now you can just do regular factorizing. Two numbers that times to make 4, I had to make minus 5. If ever you're stuck, just use quadratic formula. It's all good in the hood. The two numbers should be minus 4 and minus 1. I hope that you agree with that. I think that's right. That times is to make 4, I has to make minus 5, which means this is 0 equals x minus 4, x minus 1, which means that the roots are this one here, x equals 4, which is a root, and x equals 1, which is a root. So, guess what, guys? You have all the tools you need to sketch this relatively accurately. Here's how you do it. I'm going to switch to green, I think. Here's how you do it, buddies. You just need to label all of those points onto the picture itself. So to start with, let's just do the y equals 4, which can be up there. Boom. X is 4 and 1, so there's going to be like 1 there, and there's going to be 4 there. Now I know I don't like decimal numbers, but for the minimum point, 5 over 2, 5 divided by 2 is 2.5, so we're going to be kind of somewhere around here, midway in this thing, 2.5. And minus 9 over 4, it goes in 2 and a bit, so it's down like that somewhere. Cool. So final thing I'll put down is 5 over 2 and negative 9 over 4, and bish bash bosh, you've got it, okay? There's your points. With this many points, lovelies, look, you can just draw a smooth curvy line, because you know generally what the shape's supposed to look like. So it should be a curvy thing like that. And boom, you just got full points on a really hard sketching quadratics question. It's got 1, 2, 3 steps plus the sketch. Cool? Cool. That's the harder thing that we're going to do today, I think. But let's let you try this one. So I've got the answers all, oops, drat. I've got all the answers written down there, as you can kind of see already. So I guess I'll take you through slowly. I'll do the first step with you, then I'm going to ask you to put it on pause and try it on your own, but I'll do the first step with you. Okay. For this one here, it's 4x take 2x squared take 3. Step 1 is it's in the wrong order. The x squared term should be first, okay? All of our stuff works with the x squared term being first. So step 1 is to rearrange it. Cool. For the max, here's what I'm going to get you to do. You need to complete the square. It's a hard one, so you have to force factorize out the minus 2 first, and then just go about the same process, okay? So when you get down to this step here, even though there'll be a number here, you just need to say what would make the bracket equal to 0. Cool? So that's what you're going to do there. Y-intercept, just pop x equals 0 into that. Roots, when you're going to do the roots, just put y equals 0 in and solve it. Okay, pro tip there as well. This one doesn't factorize very well, so you're going to have to use the quadratic formula. And final step, do a sketch. Cool? So pause the video, have a go. Okay, guys, so 3, 2, 1, boom. Very tricky if you didn't quite get this right. So the max should be 1 and minus 1. There's completed square form. If you didn't get it right, just have a little pause and read through all of the steps there. It's a downward shaping one because the dominant term, the thing touching the x squared, is a negative. Cool. Y-intercept, easy peasy this one. It's minus 3. Cool. Now the roots, very interesting. Trick question, buddies. That's what you have to put into the quadratic formula, or I'll even show you when I get back. You can cheat it and put it into your quadratic formula in one step without typing anything. But you get what's called a math error, or well, not what's called a math error. You get your calculator says math error. What that actually means, guys, is no solutions. So when you're trying to find out what the roots are, it means that there is no roots. Well, it means it doesn't cross the x-axis, which means the sketch looks like that. And that's it. Cool beans, guys? If you can't put the x points on, you can't put them on. That's just the end of it. Like this one here, you could put them on, no problem. But this one here, you can't. So that's why I said math error. Cool beans? Sweet, that's topic 1 done. Topic 2, disguised quadratics, lovelies. Okay, so disguised quadratics. I'll tell you, this isn't a quadratic, this equation, because the lead term is a 6, which makes it not a quadratic at all, so it's a bit tricky. So here's what I'm going to get you to do. It is still a quadratic though. It's secretly a quadratic. It's a disguised quadratic. And here's why. There's only 2 x terms in it. One is x cubed, one is x to the 6. You notice that one is just double of the other. That means it's possible to rewrite them so that they kind of match up with each other. Now, I'll show you how that works, okay? So, first step first is you're going to do this. Let a, we just need any different variable. You could use y if you wanted. I probably wouldn't use y though because it's sometimes used for like the y direction. But let a equal the smaller one, x cubed. What does that mean that a squared equals then? What's x cubed squared? Well, x to the 6. So in other words, this exact equation can be written as a squared plus 7a minus 8. Isn't that cool and clever? Oh, sorry, equals 0. Well, because when that's done, now it's nice and easy. So I just need to figure out what two numbers times to minus 8 and add to 7. Well, it's going to be 8 and minus 1, which means we can factorize it. A plus 8, and a minus 1. That equals 0, because now it's just with a's, which means from this one that a would have to equal negative 8, and from this one, a would have to equal 1. Cool. Now that should be the final answer. However, lovelies, the question wasn't about a, it was about x. So what was a equal to again? Well, a was equal to x cubed from right up here, remember? So that bad boy there, you can now put back in. So actually, it's not a that equals 8, it's x cubed that equals minus 8. So what number times by itself 3 times equals minus 8? Well, if you said minus 2, you're dead right. X equals minus 2, like an absolute boss. Same deal here. What number times itself 3 times? Oops, so x cubed equals 1. What number times itself 3 times equals 1? Well, if you said x equals 1, absolutely right as well. Bish bash bosh. This wasn't a quadratic because the highest power is power of 6. But because one was just double of the other, it could be treated like a quadratic. It's a disguised quadratic. Cool. Happy days? Alright, good. This final one here is a bit sneakier as well, so I'm going to do it, I think, with you still. Even though I said I wasn't going to make the video long, it looks like I have made the video long, sorry. But this one here is also a disguised quadratic. X takes 7 square root x plus 10. And here's why. From your other side, from the pure side of maths that you're doing right now, what's the alternate way to write the surd of the square root of x? Well, if you said it's x takes 7x to the 1 half plus 10 equals 0, you're right. Because square roots is bottom root top power, it's going to be the square root of x. Perfect. Now, if you check it out, this follows the pattern of the disguised quadratic, because one is just double of the other. Can you see that? The half is, this is like secretly power 1, so it's double of the other. Which means we can which means that we can use our trick. So let's get our trick going. Let a, or whatever letter you like, let a equal, and it's the smaller one, x to the 1 half. Which means that a squared, square both sides, is just going to be x, because a half squared, it's like a half times 2, is just going to be x. Which means this can be rewritten as a squared minus 7a plus 10 equals 0. Cool. So just looking for two numbers that times to make 10, add to make minus 7, minus 5 minus 2 hopefully, and you're going to get this a minus 5, a minus 2 equals 0, which means that a equals 5 and a equals 2. Now you might be thinking to yourself, oh good, result, this is the final answer. But don't forget, it's not quite. The question wasn't about a's, it was about x. It was about x's. So pop this in again. You know that a was x to the 1 half. So x to the 1 half equals 5, or x to the 1 half equals 2. Well, how do you get rid of an x to the 1 half? Well, what you're going to do is you're going to square both sides, okay? Because that's the same as square rooting x. So raise both sides to the power of 2. X equals 25. Bish bash bosh. And then this one here, square it. X equals 4. So absolutely flying, solved. If you want to test them, you can test them if you like. 25 take away 7 times 5 take away 35 is minus 10 plus 10 is 0. So that one works. 4 take away minus 14, so that's minus 10 plus 10 is 0. So the two answers definitely work, and boom, you're legends. Good work, Super 12s. I know it's way harder than GCSE, especially with the pacing, but stick with it. You're going to be so good at maths, and I'm excited to see you in person. I know the pacing's quick, though. So here you go. Try this for today, please. Page 30, 1A to E, and 2. And page 27, question 7. 2 is really hard, okay? So if you're not all the way sure, ask me when I get back next week, and I'll help you out with question 2. And I guess that's it from me. So have a little go. You don't need to upload them on Show My Homework, so I'm just going to load this one up as a cover, and then we'll decide what your homework will be for next week a bit later on. Cool, guys? Cool. Keep up the good work, and see you later, my lovely 12s. Bye, buddies!